Welcome back. We are going to write our first real test, and this is going to be a long section. The first test that we are going to write is something I call a render test. It basically tests whether our component has been rendered, but since we already know that our component renders, why test it then? Of course, to avoid manually checking this again. But more importantly, the component is very simple at the moment. It will grow if you are really building a production level to do application with a lot of features. So these tests will help reduce regressions significantly. First, let us write a render test to confirm that the input and the button are rendering in the browser. All right, let us start by creating a file to store our tests. I'm going to name it app.test.tsx. This will pretty much contain the test for the entire app component. We are going to import the usual imports from vtest, which is describe and test. Describe is it is just used to group our tests. You could either use it or not use it. Completely fine if you don't use it. Great. So our test is about whether the input field and the add button has rendered. So I'm going to name it something like should render input field and add button. It would take the actual test function. Now, remember we installed testing library in the previous section. Testing library gives us a input called render, which we can use to render our React components. So I'm going to do the same over here. We get render from testing library, and this would help us render our app component. Let us also run our test. You see, you could actually call even this as a render test. If our app fails to render, this would obviously fail. But in our case, we are testing more than just the app component rendering. We are also trying to verify that input field and add button have rendered. So we have to query the DOM and make sure they exist. Before we do that, let us talk about queries. Remember the testing library's guiding principles? The whole fundamental is that our test should resemble the way our users would use our application. There are different ways to query the DOM elements. The testing library and even Playwright recommend a similar priority order for their queries. Basically, you should ideally be using get by role or get by label text most of the times, and rarely maybe reach out for something like get by test ID. And it all makes sure that your application is accessible enough. And when you test like this, your application is also guaranteed to be accessible. As discussed, at a high level, we need to use the queries that are closest to our user. In this case, this is get by role to capture both input and button. So it's going to be something like screen. So we get something called screen from testing library that helps us access the screen. Next, we get the get by role method on it. Here's what the input field could be. It is a text box. So most inputs are named as text boxes. And remember, to our input, we have a particular label. It's add task. So we could also specify that its name is basically add task. Our test already passes. In fact, screen get by role, if was unable to find the add task input field, it would fail here itself. As you can see, now I was looking for something a task, which is not available because the label is add task. And this is also another reason why I say have labels even if you don't want to display them. Now let us also check for our button, which is screen get by role. And again, this has a simpler role, which is button. And we can again give the button text, which is add in our case. Our test should pass. Here's the thing. Even though this test is complete, sometimes people like it to be more explicit. So that's what I will show you right now. But even this is a pretty much a valid test. It is verifying that our input and the button exist in our screen. But let's also do the explicit way. Let us store these references somewhere. I'm going to call it input, and I'm going to call this as button. Now, how do we be explicit? We use vtest expect input to be defined. Similarly, we do this for button. Our test will still pass. So this is an explicit way of defining this, whether something exists in our screen or not. But even this would have worked very well. There is one more improvement that we can make over here. Now, we use to be defined to check whether our input or button were present. Ideally, that is not the best matcher over here. Maybe if we could use something like to be in the document to actually verify that something is not just defined but also present in the document. And this is possible from testing library, which is called as jest DOM. So we will be installing that first. I will be attaching a link so that you could better understand what is the difference between to be defined and to be in the document in the description. It's also present in my course notes. Basically, assume that you create a button on the fly, but you have not inserted in the DOM. So it would technically be defined, but not in the document. You get the difference? Cool. Let us install just DOM. Cool. Now let us import. This is a very general import. You don't have to specifically import something from just DOM. But since we are using vtest, we will be using a vtest version of that. Again, I know this from the documentation. You don't have to worry it. For now, you can just follow this. And remember, we are going to be replacing the to be defined with to be in the document. Now, if we run our test, it should still pass. Such imports which help improve our testing experience usually happen in a separate file. People usually call it a setup file or something like that. We will also do something like that and move this particular import to that file. I'm going to create a setup.ts file outside in the root at the root of my project. Setup, I'm going to name it setup test.ts. And I will basically move my import from over my app.test.txt file to setup.ts file. Cool. You could see that there are a couple of errors, even our test fails, because Vite doesn't yet know that there is something called setup test file and that you should be considering that file. So let us do that. If we go to our Vite config.ts, inside the test property, we can let vtest know that there's a setup file. You could pass multiple files. That's why it can take an array, as you can see over here. Yeah. Since we are only passing one file, so let's explicitly define that. And let us just rerun our test. Now, our tests are passing, but yet you see red lines in our editor. This is because TypeScript doesn't yet know that. So we need to also modify our tsconfig file. So let us also do that. In our tsconfig.json, in the include, as you can see, TypeScript currently only considers the source directory. So we should also make sure that it knows about our setup file. Add the setup test.ts file, come back over here, and your red line should be gone and your test should also be passing. What we wrote right now is a pretty much the render test. We will be writing further tests, but before that, we want to make sure that we are also using ESLint to help us with testing and we don't make some silly mistakes. As I said, before we move on, let us install the respective ESLint plugins to help us write better tests. Again, I know this from documentation and a bit of Googling. For now, you can just copy this command and run it in your terminal. Let us also extend these plugins. In my ESLint, I'm going to make sure my prettier is still last and insert my plugins. Great. Now let us write one more test, which will actually test user interaction. Back in my test file, I'm going to create one more test, which would check whether my add task works. So test should test whether add task to list when maybe add button is clicked. How do we test this? We would still have our usual suspects, which is getting the input and the button. But what is now happening on the input and the button? There are a couple of events that are being fired. From testing library, we get something called fire event. Now, as I said, testing library has something called fire event, which will basically fire all the possible events on DOM elements. Remember this note, we will be coming back to this soon. What does first happen? The event fires on our input, which would be a change event, and it happens on our input. In our case, we're gonna pass in a value of maybe new task. Next, what happens is we click on our button. And this is a pretty straightforward event, which is fire event click on our button. Now, what should happen after this? We expect our screen to now have a text of new task in the document. Now, let us run our test to make sure this works. Our test passes. Now, even though our tests are passing, couple of things are not right over here. First, we are still using our old rendered app component, which we rendered in the first test for this second test too. This is not good. This can cause regressions within the test. So it is cleaner to have a new app rendered for each test. This way our tests are also isolated. Let us try doing that and see what happens. As you can see, my test fails. And if we inspect the error, it says unable to find an accessible element with the role text box and name at task. This is happening because there are basically two app components rendered at the moment, meaning there are two inputs and two buttons. So our test is unable to find that unique input and unique button. In fact, this error might not be clear enough. And usually the way we prevent this is by doing something called as cleanup after tests. So let us do that. Again, we get something called after each from vtest. And after each, what we want to do is cleanup. And cleanup comes from testing library React. ESLint is confirming about cleanups. It says cleanup is performed automatically by your test runner. You don't need manual cleanups. In our case, we still need to. Usually you could specify this in our vtest configuration in our globals. Since we're not doing it, there's a better way to do it. We will be using our setup file to do that. So in our setup, we could basically import cleanup from testing library and also import after each from vtest. And basically here we could do that cleanup. And in our actual test file, we could remove this code. Now, if you run your test, they should be passing. Our code is also a lot simpler because of the setup file. Great. Even though our tests are passing, we have a flaky test. Let us first try to amplify the problem so you understand why our test is flaky. Go back to app.tsx and on your input, just make the input read only. Now, if you try to manually try to insert in our input, nothing happens because it's a read only field, but our tests are still passing. This is basically a flaky test. And remember the note about firing events? This was the note. The testing library's fire event method is good for few cases when you maybe ideally want your tests to run faster. But in most cases, we should be using something called user events. In fact, user events is the recommended way for testing user interactions. Again, we need to install this as a package. Let us do that. My course notes has the command linked. You can use that command. Let us install it. The difference between fire event and user event is fire event happens synchronously, whereas user event tries to emulate actual user. So user events are asynchronous. So let us first import user event. And this comes from our testing library user event. Our test would now be asynchronous. And we need a user to mimic all those events. Now, wherever we were doing fire event, let's try to write the equivalent, better equivalent of it using our user, which would be await user dot type. User actually types in the input. What is he typing? New task. We can remove this fire event change. Next, the user also clicks on the button. Pretty standard method. We can also remove the fire event for button. Our expect won't work. We should ideally be using something called await wait for. So this is going to wait for a couple of seconds, a couple of milliseconds, I would say. And in this wait for, we can run this expect, and this would work. Now let us run our test. Our test will fail because our app code is wrong, because we have a read only over here. And if we remove that, our test passes. This means that we have a better test compared to the older one with fire events. This is why even the docs recommend user events over fire events. And ideally, as you can see, it's an asynchronous test. They can sometimes end up being slow. You got to weigh your pros and cons. Usually, most of the times, user event works well. But if you want to have faster test, maybe you could switch it for fire events. Let us clean up our code and commit it. I'm gonna just name it base test. Cool. See you in the next section.